All right, so today's lesson is sort of a refresher because we've already talked about combined events, mutually exclusive and independent, but we're going to put it together with all of our formulas. So we learned that events are mutually exclusive if they cannot occur at the same time. So the probability of A union B is going to be the probability of A plus, plus the probability of B. Since it's normally this minus the probability of A union B, A intersect B, that means that the probability of A intersect B is equal to 0 when we have mutually exclusive. If they're independent, this is a different meaning. So the probability of one thing happening does not depend on the outcome of another. So normally we know that the probability of A given B is equal to A intersect B divided by probability of B. But now we're saying it doesn't depend on what happened with B. So the probability of A given B, it doesn't matter. It's still just going to be whatever the probability of A is. So if we think about our normal formula that we had probability of A given B was the probability of A intersect B divided by the probability of B. But now if we're saying that this is independent, so if that's independent, then this is just the probability of A, which means that that's still the intersection divided by probability of B. If we multiply probability of B to the other side, we get the probability of A intersect B is probability of A times probability of B. And this is how we originally defined independent events. We said that if these two don't depend on each other, then the probability of both of them happening is the probability of one times the probability of another. Think about flipping two coins. The probability of heads is 1/2 times 1/2. So if they're independent, probability of A intersect B is probability of A times probability of B. So let's look at an example of this. So probability of A is 1/2. That is supposed to say B, of course. Probability of B is 1/3. So find the probability of A union B if they're mutually exclusive. Well, if they're mutually exclusive, probability of A union B is probability of A plus probability of B. So we do 1/2 plus 1/3. If we put this into our calculator and added it up, we would get 4 out of 6 or 2 out of 3. 3 out of 6, 5 out of 6, sorry. So put it in your calculator. Don't just try and think about it in your head. You get 5 out of 6. Now, if they're independent, that means that our formula for A union B must be probability of A plus probability of B minus probability of A intersect B. Well, if they're independent, then I know probability of A intersect B is those two multiplied. So I'll have P of A, I'll have 1/2 plus 1/3 minus 1/2 times 1/3. So that we know from earlier, that's 5 out of 6 minus 1 out of 6. That's 4/6 or 2/3. So that's how we would do it if we just have letters. We don't have to make any sort of picture. We can use the formula, and these formula are in our formula booklet.